you all doing well. In our previous session, we have discussed something about what is inside atom. Today, we will continue our topic what is inside atom, and we will discuss some interesting new concepts of this topic. Children, after completion of this session, you will be able to understand about distribution of electrons. Children, after completion of this session, you will be able to understand about distribution of electrons in different orbits and concept of valency, and also understand and differentiate between atomic number, atomic mass number, understand isotopes, and are able to determine atomic masses of isotopes. Children, you will be able to know applications of isotopes. In our previous session, we have discussed about subatomic particles. There are three subatomic particles inside the atom: electron, proton and neutron. Electron is negatively charged subatomic particle, proton is positively charged subatomic particle, and neutron neutral. Electron mass is negligible, as proton mass is 1836 times more than the mass of electron. Neutron mass almost equal to the mass of proton. Children, we also discussed structure of atom and some models of atom. The first model of atom, Thomson's model of atom. In Thomson's model of atom, we discussed that all the positive charge of the atom uniformly distributed throughout the atom, and the negatively charged particles electrons were embedded in the sea of positive charge, as like seeds of watermelon in the red fruit pulp of watermelon, and it is also known as plum pudding model. Rutherford's model of atom, this model purely based on the observations of Rutherford's alpha particle scattering experiment. By the observation of alpha particle scattering experiment, Rutherford concluded that most of the space inside the atom is empty. Very small region of space inside the atom is accumulated in the center of the atom. In the small region of space, all the positive charge and mass of the atom is accumulated, that is known as nucleus of the atom. Around the nucleus, the electrons are revolving in circular paths as like planets in the solar system. Children, we also discussed Bohr's model of atom in our previous topic. In the Bohr's model of atom, we know about energy levels. The electrons revolve around the nucleus in discrete fixed circular orbits of the atom. These orbits or shells are called stationary energy levels. At the center of the atom is nucleus. Around the nucleus, various shells are present, and these are circular orbits. These orbits named as K shell, L shell, M shell and N shell, and also indicated with n equal to 1, n equal to 2, 3, 4 and so on. As moving from nucleus to far away, the shell number increases. These shells also known as energy levels. While revolving in these discrete orbits, the electrons do not radiate energy, and this is the reason why electrons do not fall into nucleus. The electron orbits or shells are represented by the letters K, L, M, N, or the numbers n equal to 1, 2, 3, 4. By studying all these models, we know that how the electrons are distributed inside of the atom. Children, now we will discuss our today's topic, the distribution of electrons in various orbits or shells. This distribution of electrons in different orbits was suggested by Niels Bohr and Bury scientists. The K shell, that is n equal to 1 shell, is closest to the nucleus and has lowest energy. The next shell, further L shell n equal to 2, has higher energy than K shell, and so on. M shell, N shell, etc. As moving far away from the nucleus, the energy of the shells increases gradually. The first shell, K shell, is lowest energetic shell and the outermost shell has highest energy. Children, you might have excited how many electrons are distributed in each shell. What is the criteria for distribution of electrons in various shells? Let us discuss how the distribution of electrons takes place in various shells. How many electrons can be accommodated in each shell of an atom? Can a particular shell have just one electron? What is the criteria to decide number of electrons in a shell? To find out the answers for all these questions, we have to study the rules framed by Niels Bohr and Bury. Bohr and Bury rules for electron distribution. The rule number 1, the maximum number of electrons present in a shell is given by the formula 2n square, where n is the shell number, that number will be 1, 2, 3, 4 as moving from the nucleus to outermost shell, the shell number increases. The rule number 2 is each shell or energy level is further divided into subshells. The maximum capacity to hold electrons in the outermost shell is 8. Children, let us calculate the maximum capacity to accommodate electrons in each shell. We will discuss from K shell. K shell, shell number n equal to 1. So, by substituting this value in 2n square formula, 2 into 1 square equal to 2. That means, in K shell, the maximum capacity of electrons to accommodate is 2. In the similar way, let us find out in other shells. N equal to 2, that is L shell. In L shell, 2 into 2 square equal to 8 electrons are accommodated. And in M shell, n equal to 3, 2 into 3 square equal to 18. And in the similar way, the N shell, that is the fourth shell, 2 into 4 square equal to 32. This table tells about the maximum capacity of each shell to accommodate electrons. First shell 2 electrons, second shell 8 electrons, third shell 18 electrons, fourth shell 32 electrons. And the third rule is the electrons will fill the inner shells before the outer shells. The first electrons will fill the K shell and then L shell and so on based on their energy increasing order. For example, we will discuss electron distribution in oxygen atom. We all know the atomic number of oxygen is 8, that is Z equal to 8. It has 8 electrons. Out of 8 electrons in the K shell, n equal to 1 shell, the first 2 electrons fills and the remaining 6 electrons goes into L shell, that is n equal to 2 shell. So, that the electronic structure of oxygen atom is 2, 6. In the oxygen atom, around the nucleus 2 shells are there. The first shell is K shell. In the K shell, 2 electrons are accommodated and the next shell is L shell. The remaining 6 electrons are accommodated in L shell. And we will discuss some other elements electron distribution. The first element is hydrogen and the atomic number of hydrogen is 1. It consisting of only 1 electron. That 1 electron obviously goes into the first shell, that is K shell. So, the electron distribution of hydrogen is 1 only. In that 1 electron goes into the first shell itself. In the similar way, helium atomic number is 2, that means it has 2 electrons. Both the electrons accommodated in the first shell. The maximum capacity of first shell to accommodate electrons is 2. Both the 2 electrons are accommodated in first shell. So, the electron distribution of hydrogen is 1 and the electron distribution of helium is 2. So, other elements lithium to neon, how the electrons are distributed we will see. The next element is lithium. Lithium is having 3 electrons. In the first shell 2 electrons are accommodated and the remaining electron goes into the next shell, L shell. So, electron distribution of lithium is 2 1. The next element is beryllium. Beryllium atomic number is 4. 4 electrons are there in beryllium atom. These 4 electrons distributed in 2 shells. First 2 electron goes into K shell and the remaining 2 electrons filled in L shell. The electron distribution of beryllium is 2 2. In the similar way, the next element is boron. Its atomic number is 5. These 5 electrons are distributed in 2 shells, K shell and L shell. The first 2 electrons fill in K shell and the remaining 3 electrons fill in L shell. Electron distribution structure of boron is 2 3. In the similar way, carbon atomic number is 6. 6 electrons are distributed in 2 shells. First shell 2 electron, second shell 4 electrons, K shell 2 electrons and L shell 4 electrons. Electron structure of carbon is 2 4. The next element is nitrogen. Its atomic number is 7. 7 electrons are present in nitrogen atom. These 7 electrons are distributed in 2 shells. The first shell K shell 2 electrons and the next shell 5 electrons. The electronic structure is 2 5 for nitrogen atom. Oxygen atom just now we have discussed, its structure is 2 6. And the next element is fluorine. Fluorine atomic number is 9. 9 electrons are present in fluorine. Out of 9 electrons, 2 electrons fill in first shell and the remaining 7 electrons fill in next shell, L shell. The electronic structure is 2 7. And neon, its atomic number is 10. It consisting of 10 electrons. Out of 10 electrons, 2 electrons fill in first shell and the remaining 8 electrons fill in second shell, L shell. For neon, first shell and second shell both are filled up to its maximum capacity. The next element is sodium. Sodium atom atomic number is 11, that means it contains 11 electrons. These 11 electrons are distributed in 3 shells, first shell 2 electrons and second shell L shell 8 electrons and 1 electron is remained, that electron goes into the next shell n equal to 3 shell, M shell. So, the electronic structure of sodium is 2 8 1. Children, after understanding the distribution of electrons in various shells of atom, we will discuss the next topic, valency. Carbon atom consisting of 6 protons, 6 electrons, 6 neutrons. The electron distribution of carbon, around the nucleus 2 shells are present. In the first shell 2 electrons and the next shell 4 electrons are accommodated. Here the second shell is the outermost shell of carbon atom. In this outermost shell 4 electrons are present. The electrons present in the outermost shell of an atom are known as the valence electrons. For carbon atom, in the outermost shell 4 electrons are present, that means carbon valence electrons are 4. Valency, the combining capacity of an element is known as valency. This valency can be determined by knowing the valence electrons. Valence electrons nothing but the number of electrons present in outermost shell of an atom. For example, valency of boron is 3. That means, the number of valence electrons of boron is 3 and valence can also determined by using formula 8 minus number of valence electrons if valence electrons are greater than 4. Mainly the valency explains combining capacity of element with other element. For example, fluorine atom has combining capacity 1. That means, it will combine with one other element. and the combining capacity of oxygen is 2. That means, the oxygen element can combine with other 2 elements. Lithium element atomic number is 3 and electron distribution, first shell 2 electrons, second shell 1 electron, second shell is the outermost shell. The number of electrons present in outermost shell or valency electrons. Here the valency electrons for lithium atom is 1. This value is less than 4. So, the valency combining capacity of lithium is 1. In the similar way, let us discuss valency of fluorine. Fluorine atomic number 9 and electron distribution, we know that 2 7. In the outermost shell 7 electrons are present. The valency of fluorine can be calculated using the formula 8 minus valency electrons, 8 minus 7, that equal to 1. So, fluorine atom combining capacity is 1, it can combine with one another atom. Some other examples, valency of hydrogen, lithium, sodium, fluorine is 1 and the valency of beryllium, oxygen, magnesium is 2. Valency of boron, aluminum, nitrogen elements are 3. Let us see the table which is consisting of valency of 18 elements. From hydrogen to sodium, now we will discuss from magnesium. Magnesium atomic number 12 consisting of 3 shells, 2 electrons in first shell, 8 electrons in second shell and 2 electrons in third shell M shell. Outermost shell is M shell, it contains 2 electrons. So, the valency of magnesium is 2. In the similar way, aluminum 2, 8, 3, outermost shell consisting of 3 electrons, its valency is 3. Silicon 2, 8, 4, outermost shell of silicon consisting of 4 electrons, so that its valency is 4 as like carbon. And phosphorus atomic number is 15 and the electrons are distributed into K, L, M shells 2, 8, 5. The outermost shell consisting of 5 electrons, so that its valence electrons are 5 and the valency is calculated as 8 minus 5 equal to 3 and this phosphorus exhibits variable valencies 5 and 3. In the similar way, sulfur also exhibits variable valencies 2, 6 as its outermost orbit consisting of 6 electrons, 8 minus 6 equal to 2 and 6 variable valencies are there for sulfur. Chlorine atom atomic number 17 and the electrons are distributed in 2, 8, 7. 7 electrons are present in outermost shell M shell. So, its valency is 8 minus 7 1 as like fluorine atom. And the interesting thing is argon, its atomic number is 18. In the electron distribution of argon, first shell 2 electrons, second shell 8 and the third shell is also 8, outermost shell consisting of 8 electrons. So, that its valency 8 minus valency electrons 8, 8 minus 8 equal to 0, that means argon element does not combine with any other element. So, what is the importance of this valency? Here from our discussion we know that helium, neon, argon, these elements has 0 valency. That means these elements does not combine with other elements. So, these are inert or noble gases and highly stable unreactive species. Helium, neon, argon, electron distribution in K, L, M shells. Helium, only 2 electrons are present in helium atom. So, those 2 electrons filled in K shell. Neon, K shell and L shell is filled. For argon, K shell 2 electrons, L shell 8 electrons and M shell 8 electrons are present. All noble gases except helium have 8 electrons in their valency shell. because of these 8 electrons in their valency shell, their combining capacity becomes 0. That means, these gases are inert and highly stable. The octet rule. An atom with 8 electrons or an octet in their outermost shell does not combine with other atoms. The octet rule can be stated as atoms of main group element tends to combine in such a way that each atom has 8 electrons in its valence shell, that is noble gas configuration. Presence of 8 electrons in outermost shell is known as noble gas configuration. The atoms can achieve an octet by transfer of electrons and also by sharing of electrons. By transfer of electrons, by sharing of electrons, formation of bonds will takes place. Children, after knowing octet rule and reason for stability of noble gases, we will discuss the next topic, atomic number and atomic mass number. Why do atoms of different elements are different? Atoms of different elements have different number of protons in their atomic nuclei. The atomic number is the number of protons in the nucleus of an atom. Atomic number indicated with letter Z. Atomic mass number A. Mass number is the nearest numerical to the mass of an individual atom. Mass number is the number of protons Z plus the number of neutrons. Atomic mass number A equal to atomic number Z plus number of neutrons n, A equal to Z plus n. From this, number of neutrons equal to A minus Z. Writing symbols of atoms after knowing atomic number and atomic mass number. Along with the atomic number and atomic mass number, the symbols of atoms can be written as like this. For example, fluorine atom, its atomic number is 9 and mass number is 19. Atomic number is written as subscript and atomic mass number written as superscript. 9 is number of protons, that is atomic number. 19 is atomic mass number, that means number of protons plus number of neutrons. Number of neutrons equal to A minus Z, that here for fluorine 19 minus 9 equal to 10. Isotopes. Every element has unique atomic number, but not atomic mass number. The atoms of the same element which have the same number of protons, but have different number of neutrons are called isotopes. For example, hydrogen, naturally occurring isotopes are 3. Atomic mass number 1 protium, atomic mass number 2 deuterium, atomic mass number 3 tritium. 1H1 protium, 1H2 deuterium, 1H3 tritium. Protium, there is no neutrons. In deuterium 1 neutron and tritium 2 neutrons are present. The chemical properties of isotopes are similar, but their physical properties are different. Carbon element is also naturally occurring 3 isotopes: carbon 12, carbon 13, carbon 14. These 3 isotopes are naturally occurring isotopes. How do we determine the atomic mass of an element with isotopes? Isotopes are having different mass numbers. Atomic mass of isotopes, in nature most elements occur as mixture of 2 or more isotopes. Each isotope has a certain percentage of natural occurrence. For example, 17 chlorine 35 isotope 75% abundance, 17 chlorine 37 25% natural abundance. The atomic mass of an element is taken as an average mass of all the naturally occurring atoms of the sample element. For example, 17 chlorine 35 isotope 75% natural occurrence, 17 chlorine 37 25% natural occurrence. Average atomic mass of chlorine atom can be calculated by using this average formula: 35 into 75 by 100 plus 37 into 25 by 100, that equal to 142 by 4, that can be simplified as 35.5 units. That the average atomic mass of chlorine atom is 35.5 units. The applications of isotopes. Isotopes are very much useful in the investigation of steps in various chemical reactions, that is study of reaction mechanism of certain chemical reactions using isotope labeling technique. And these isotopes can also used to solve chemical and medical mysteries. Uranium isotopes are used in nuclear reactors as fuel in nuclear reactor. Cobalt isotopes mainly used for the treatment of cancer. Iodine isotopes are used for the treatment of goiter, a thyroid disease. Children, after knowing these concepts, let us recapitulate what we have learnt in this session. An atom is the smallest particle of an element that retains the identity of the element. According to Dalton, atoms are very small indivisible particles that make up all matter. All the atoms of same element are identical in mass and size, but atoms of different elements are different. The three subatomic particles of an atom, one is electron negatively charged, proton positively charged, neutron neutral. J. Thomson developed a model of an atom that shows electrons embedded throughout the mass of positively charged material. Rutherford's alpha particle scattering experiment. Ernest Rutherford's model of the atom, it is defined nucleus. Niels Bohr model of the atom introduced energy levels concept, that energy levels around the nucleus, and the atomic number of an element is same as the number of protons in the nucleus of its atom. The mass number of an atom is equal to the number of nucleons in its nucleus. Valency is the combining capacity of an atom. An atom with 8 electrons or an octet in their outermost shell is chemically stable or does not combine with other atoms as its combining capacity 0. Isotopes are atoms which have the same number of protons, but a different number of neutrons. Children, I hope you all understood the concept of this lesson. Let me evaluate what you have learned in this topic. To improve your learning, answer the following questions. Let us improve our learning. What are the three subatomic particles? What were the three major observations Rutherford made in the gold foil experiment? Give the main postulates of Bohr's model of an atom. What are the limitations of J. Thomson's model of the atom? State the valency of sodium atom. To practice the concepts of this lesson, visit SERT Telangana official website and download worksheets, practice the assignments. Children, today we have learnt about what is inside atom lesson. I hope you all understood this lesson, and I hope we will meet again in another sessions. Till then, goodbye.